Good day, economics students, and welcome back to part 2 of Theory of the Firm, Cost of Production, Video Economic Analysis. If you have not yet watched part 1 of this video, I strongly suggest you watch part 1 prior to moving on to part 2. I do apologize that part 1 of the video series covering cost of production does have a minor audio issue at the very end. For that reason, going to cover the same 2 slides at the end of that video at the beginning of this video, just to make certain all students have access to and are informed of these important cost concepts. So if you remember hearing these ideas at the end of the last video, good. It's always important to reinforce these important cost ideas. So we are analyzing the theory of the firm in the short run, the period of time when the size of the plant, the factory, the firm is fixed, and we are analyzing the relationship between our fixed capital and our variable inputs such as materials and labor. Remember, for an economist, the short run is not a specific time. It is completely dependent on the nature of the industry. For instance, an automobile manufacturing plant may take 7 years to acquire land, build a factory, and equip it with machines, whereas some small manufacturing firms, such as a parts manufacturer for appliance, can perform the exact same process of constructing a plant, equipping it with machines, and being up and ready to run within 2 years. So the short run is not a specific amount of time, rather it's dependent on the nature of the economic nature of the industry. Let's review these important short run cost concepts: average fixed cost, average variable cost, average total cost, and marginal cost. Average fixed cost is simple to calculate. Total fixed cost divided by quantity. So if you know the firm's short run fixed cost and divide it by the quantity of output, you can easily calculate the firm's average fixed cost. Remember, fixed costs are unavoidable and do not vary with the firm's level of output. Right? Fixed costs are not related to the firm's level of production, and these costs are unavoidable. So for instance, rent or insurance. Let's consider a small parts manufacturer again. Let's assume they're making parts for appliances. So they have to pay rent for the building they are operating, and they have to pay insurance to cover their potential liabilities. The insurance company and the owner of the building do not care how many units are produced per day, per week, per month, or per year, so those costs will not vary with the firm's level of output. So average fixed cost, total fixed cost divided by quantity of output. One important note about average fixed cost: if you calculate the firm's average fixed cost at 1 unit of output, it will also equal the firm's total fixed cost. That is called the identity principle. Any number divided by 1 is, of course, that number. So if you were given this information on a test, a quiz, or simply just needed to know the firm's fixed cost, you could look at average fixed cost at 1 unit of output, and that would give you the firm's fixed cost in the short run. Average variable cost, total variable cost divided by quantity of output. We will see on the next slide that the average variable cost curve reflects the law of diminishing marginal returns, the relationship between fixed capital and our variable inputs in the short run, and the idea that it is impossible to continue to add variable inputs to a fixed resource and expect output to increase eternally. And we will talk about that more in detail in the next slide. If we simply take average fixed cost plus average variable cost, it will add up to average total cost. So you could calculate average total cost in one of 2 ways. You could simply take average fixed cost plus average variable cost, and that would give you average total cost. Or you could take total cost divided by quantity of output, and that would give you average total cost. Marginal cost. Economic thinking is marginal thinking. Most decisions involve changes in the status quo. Marginal cost, the cost associated with producing the next unit of output. How much will cost rise if the firm decides to produce one more unit of output? So notice, change in total cost over change in quantity is the calculation for marginal cost. Now let's take a look graphically at our cost structure, our averaged cost curve structure in the short run. First, our green average fixed cost curve. Whenever you use graphical analysis to make sense of economic principles and concepts, be certain you identify what is being measured on each axis. On the horizontal axis is quantity of output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units produced. Now, this could be units produced per day, per week, per month. Right. Just know that it's units produced for a specific amount of time. On the vertical axis, we have costs in dollar terms. 0, 50, 100, 150, 200. So our first cost curve, our average fixed cost, is calculated by taking the firm's total fixed cost divided by quantity of output. Evaluate average fixed cost at 1 unit of output. 100 divided by 1 equals 100. So obviously at 1 unit of output, average fixed costs equals total fixed cost. Notice the steepness of the average fixed cost curve. Output increases from 1 to 2, average fixed cost decreases from 100 to 50. Increase output by another unit, average fixed cost falls from 50 to 33.33. With 4 units produced, average fixed cost is 25, with 5 it's 20, and so on. This is sometimes referred to as spreading out the overhead. Calculate average fixed cost at 10 units of output. 100 divided by 10, average fixed cost at 10 units of output is 10. Next up, our average variable cost curve. First, evaluate the shape of the average variable cost curve. It's a U-shaped curve. Average fixed costs are rather high at a low level of output, fall for a certain amount of time, and then begin to rise. That is the U-shaped curve, average variable cost curve, is demonstrating this idea that average variable costs are high with a low level of output, fall for a certain amount of time as output increases, and then begin to rise. The average variable cost curve reflects the law of diminishing marginal returns, an economic concept we covered in the previous video. In the short run, the size of the factory is fixed. As we add a variable input, we typically analyze the variable input labor. As we add a variable input to our fixed factory, our fixed capital, output increases initially at an increasing rate, then it increases at a decreasing rate, and then it actually would fall. That's from the standpoint of production. The average variable cost curve reflects this same idea from the standpoint of costs. Average variable costs are high when you are only producing 1 unit of output, but as output increases and the factory is used or utilized more efficiently, average variable costs fall. Then beyond some level of output, diminishing returns begins to set in, and therefore average variable costs begin to rise. If we simply take our green average fixed cost curve plus our yellow average variable cost curve, we can calculate our average total cost curve. So green plus yellow equals red, our average total cost curve. Finally, the marginal cost curve. Ever important, marginal cost. Remember, marginal cost is change in total cost associated with producing the next unit of output. Any economic concept measuring marginal is always going to be related to change in something, in this case marginal cost, change in total cost associated with producing the next unit of output. So this graph conveniently displays all four of our cost curves. We will not spend a great deal of time evaluating the average fixed cost, the green curve down bottom. However, the other three cost curves, the marginal cost curve, the average variable cost curve, and the average total cost curve, will be vitally important to our understanding of the cost structure of the firm in the short run, especially as we apply this cost structure to our study of the four market models of pure competition, monopoly, oligopoly, and monopolistic competition moving forward. Let's quickly evaluate the relationship with the marginal cost curve and the average variable cost curve, and then of course the relationship between the marginal cost curve and the average total cost curve. Notice that the marginal cost curve intersects the average variable cost curve and the average total cost curve at their minimum point on the curve. Why is this? Well, okay, as long as marginal cost, the cost associated with producing the next unit of output, is falling, so if it costs the firm less to produce the second unit of output than it did the first unit of output, marginal costs are falling, that will bring down the average variable cost. And as long as marginal costs continue to fall, average variable costs will continue to fall. However, once marginal costs begin to rise, average variable costs will also rise. They will rise in lockstep with the increase in marginal cost. The same is true because part of the average total cost curve is made up of the average variable cost. So as long as marginal costs are falling, average total cost will also be falling. When marginal costs begin to rise, average total cost will begin to rise. We have been concentrating our economic efforts on the short run analysis, the period of time when the size of the plant is fixed and the relationship between our variable inputs and our fixed capital. Remember, we can evaluate this relationship either from the standpoint of production or from the standpoint of costs. So we could compare marginal cost and marginal product. Remember, marginal product is the change in total product associated with hiring the next worker. The firm evaluates, is it worth hiring the next worker? The firm could also evaluate the relationship between adding variable inputs to its fixed capital from the standpoint of cost. The change in total cost, marginal cost, associated with producing the next unit of output. We will look at this relationship graphically on the next slide. It is important to remember in the short run, firms make decisions at the margin. Is it worth producing the next unit of output? This will become ultimately clearer when we apply our cost structure analysis, our economic analysis of the firm's short-run cost structure to the market models moving forward. But it's an important point to make now that a business will consistently, constantly evaluate the marginal decision of producing the next unit of output. On the previous slide, we emphasized the relation between marginal cost and average variable cost and average total cost. The idea that the marginal cost curve would intersect the average variable cost curve and the average total cost curve at their lowest points, because as long as marginal costs are falling, average variable costs will also fall. When marginal costs begin to rise, average variable costs will rise. That same relationship holds true between marginal cost and average total costs. If the cost of producing the next unit of output is lower than the previous unit of output, average total cost will fall. When marginal costs begin to rise, average total cost will begin to rise. So we're going to look now graphically at the relationship between the productivity curves and the cost curves. Later on, we will talk about what factors might shift the curves. All right, let's talk about what's being measured on the top graph versus the bottom graph, right? So our top graph is our what? Marginal product curve. On the horizontal, we're measuring quantity of labor, number of units of workers employed at the factory, right? On our vertical axis, we're measuring average and marginal production in number terms. So, as we add workers to our fixed resource, our factory, the marginal product of each worker increases for a certain amount of time. It reaches a maximum, and then the marginal product of the next worker begins to fall. We refer to this as the law of diminishing marginal returns. We see this as the black point at the apex on the marginal product curve. Right? That idea that you can't expect to continually add a variable input to your fixed resource capital and expect production to increase infinitely, indefinitely, forever, ad nauseum, eternally. Well, the same idea can also be analyzed from the standpoint of cost down bottom. On the horizontal axis for our bottom graph, we're measuring quantity of units produced, quantity of output. On the vertical axis, we're measuring, in dollar terms, costs. Marginal cost is the change in total cost associated with producing the next unit of output. As we add variable inputs to our factory, marginal cost of producing the next unit of output falls for some time. We are using the factory more efficiently, therefore the marginal cost of producing the next unit of output falls for a period of time. Notice at the lowest point on the marginal cost curve, another black spot denoting the point at which the law of diminishing returns sets in. Beyond that level of output on the quantity axis, marginal costs begin to rise. Not because we're worse at what we're doing, or because the next worker isn't efficient, or because somehow the factory is not as technologically advanced as it once was. No, it's simply because of the law of diminishing returns. Now we can compare marginal product to marginal cost, right? It's two sides of the same coin. The top graph shows us the short-run relationship between marginal product based on adding workers to our fixed resources from the production standpoint. The bottom graph evaluates that same short-run relationship between variable inputs and fixed resources from the standpoint of costs. It's like what my good friend and economic colleague calls spiders doing push-ups in the mirror. Now, what is true for the marginal product marginal cost relation is also true for the average product average variable cost relationship. So notice that when average product is rising, average variable costs are falling. That is to say that the efficiency of the factory is increasing in terms of production in the top graph, which means that the average variable costs continue to rise due to these efficiencies as measured in the bottom graph. Beyond some level of production, average product begins to fall. At that point, the firm starts to experience an increase in average variable cost of production. So let's change our focus from the short run, the period of time in which the size of the firm or the capital is fixed, to the long run when all inputs are variable, including the size of the plant. So remember, this is specific to the type of industry we are analyzing. If we were analyzing light manufacturing, it might only take a year for a business to acquire land, erect a factory, and equip it with machines to double its productive size. If we're evaluating the production of airplanes at Airbus or Boeing, it might take 12 years for these firms to build a factory, acquire the machines, set them up, get the zoning, and all such necessary allocative decisions to get the plant up and running. So the long run differs with the specifics of the industry. And we will talk about how these different industries will have different types of long-run productive cost curves based on the characteristics of the industry. Right? So, how do we therefore construct the firm's long-run average total cost structure? What's being measured on our graph here? Down bottom we have output, number of units produced. On the vertical axis we have average total costs. So if we take our average fixed cost plus our average variable cost, that gives us the firm's average total cost curve. Let's concentrate our efforts on ATC-1, ATC1, average total cost curve 1. Let's assume this is a small manufacturing firm, and for a time the average total cost of each unit of output declines because the firm is beginning to operate more and more efficiently within the confines of its fixed capital, its fixed plant. However, beyond some level of output, costs begin to rise because of diminishing marginal returns. When costs begin to rise, it makes sense for this firm, this producer, this business, to seek out a way to expand production. So if they have the opportunity, because remember the long run is a period of time when all resources, including the size of the plant, are variable. If they have the opportunity, the time, and of course the economic ability to expand production, the firm is no longer restrained by ATC1, average total cost curve 1. They can increase the footprint, the size of their factory, their plant to ATC2. So think they've acquired another building, or they've abandoned their old building and constructed a new building twice as large as the previous building. Now we can continue with this analysis, saying, okay, beyond some point of the size of that building, costs would begin to rise, and the firm would seek out in the long run the ability to expand again. If we take all of our short run average total cost curves, we can construct therefore the long run average total cost curve for the firm. Is there an advantage to growing larger as a firm? Is there an advantage to expanding in the long run? We're going to discuss in detail this idea of what economists refer to as economies of scale. We'll talk about the economic logic behind economies of scale on the next slide. Let's just talk about the idea mathematically, so therefore you can understand the conceptual explanation of this economic principle on the next slide. Assume that a firm is able to expand to the point where they are producing Q3 level of output. This firm has grown quite large as far as its capacity to produce. At Q3 level of output, let's call this 300. Let's assume this firm is now producing 300 units per week. They are achieving an average total cost of AC3. Let's assume that number is 25. So if the firm can grow large enough where they have the capacity to produce Q3 level of output, the lowest point on their long run average total cost curve, the average total cost per unit of production is much lower than would be otherwise if the firm was constrained by smaller factory size. Now, this is going to matter as far as the firm's competitive advantage. Let's talk now about why economies of scale exist, but just keep this in the back of your mind that as a firm grows larger, they're able to produce more output and therefore achieve a lower average total cost per unit. Why do economies of scale exist? Well, economists refer to a few ideas. Let's look at the third one first, this idea of efficient capital. When you talk about the contributing factors which lead to or generate economies of scale, generally talking, efficient capital is the most important idea. If a business invests heavily in machinery, they make a significant capital investment, As you crank out more output, it makes much better economic sense regarding the expensive investment in capital that was necessary up front. So there's a significant upfront expenditure on capital that's required to grow that large. As you use these machines, this investment to produce more, average total cost per unit will drop. In the real world, think about a company like Ford Motor Company or Toyota or GM. There is a machine which these automobile manufacturers use to produce cars that attaches the frame to the chassis. This task used to take hundreds of hours and it was labor intensive. The $30 million Stomper, which completes this job in less than 10 minutes, obviously makes sense as far as a capital investment if the firm's in a position where they're going to crank out a large number of production. If production is small, making such a large capital investment would not make sense. So this idea of efficient capital, large expenditures on machines and equipment the size of the factory, which make economic sense because the firm is able to produce enough units of output to make use of, to efficiently use their investment in these machineries. Another idea is this idea of managerial specialization. Let's think about the world of a manager. Could I manage 10 people efficiently? Well, in a small factory, I could easily manage 10 people efficiently. But what about 100 people? Now, this might sound ridiculous, but if I had 10 cameras, and these cameras were focused on workspaces, and there were 10 people in each workspace, I could keep track of 100 people. And if we used computerization to measure not only the activity of people through visualization and live video, we can also have quality control based on computer measurement of meeting certain specifications when it comes to production. So this idea of management specialization, that highly trained, highly intelligent engineers or specialty managers are able to control the process of not just a few people, but of many people, and do it in a more efficient way that may even be possible in a smaller factory with technological advancement. Another idea is what we call labor specialization. Think about your first day at any job. You have no idea what's going on. You ask a lot of questions. You're a little unsure of yourself. You don't want to do anything that's incorrect to either wreck the process or anger your coworkers. But after you've been in this position 6 months, a year, 5 years, you're an expert. You know all the tricks of the trade. You know all the shortcuts to save time. You know exactly what to do to make the outcome nearly perfect. Right? This holds true in a factory when you have people performing the same task over and over. This idea of labor specialization. Now, other factors, this is what's called economies of scope. The idea that as you do something, you grow more accustomed to it, and therefore you are much better at that activity. If we combine these ideas, these other factors, efficient capital, management specialization, and labor specialization, it leads to economies of scale. So now that we looked at the graph originally and discussed the economic rationale behind the long run average total cost curve, we can understand economies of scale. Again, quantity of output measured on the horizontal, average total cost per unit measured on the vertical. The idea of economies of scale is that firms who are able to grow large through capital investment, significant capital investment in large manufacturing industries, can achieve an average total cost per unit of output much lower than would-be competitors. This phenomena is going to ultimately impact the competitiveness of the industry. For instance, let's assume that we'll call them 15 predominant automobile manufacturers in the world have all achieved economies of scale through massive investment in factories and equipment, the machines that they own and are on their balance sheet as assets in their manufacturing facilities across the globe. This massive investment in capital allows each of these manufacturers to achieve an average total cost per unit at AC3 because they're cranking out Q3 level of output. Let's assume this is the average total cost per year. So in other words, if you think about Toyota, GM, Ford, Volkswagen, Subaru, Honda, Mercedes, right? They produce hundreds of thousands of automobiles, which makes their significant costly investment in capital worthwhile because they achieve an average total cost per unit as low as AC3. If a new automobile manufacturer wanted to enter this industry and only had a factory size as large as the short run average cost curve labeled 1 up top here, they would be producing at Q1 level of output. Their average total cost per unit would be far greater, far higher than the existing automobile manufacturers. All right, so see how much higher AC1 is than AC3. Now you could use actual numbers if that helps. Let's assume that, now I know that not all cars are the same, but let's assume that the large manufacturers are able to produce a car at an average total cost per unit of $25,000 per unit, whereas a would-be competitor, because their factory is only large enough to achieve an average total cost per unit of AC1 at Q1 level of output, their average cost per unit could be $65,000 per car. So therefore, this idea of economies of scale, it's going to have an impact on the competitiveness of the industry. Now that we have introduced and understand the economic concept of economies of scale and understand why large manufacturing industries which require significant capital investment will be dominated by fewer firms, let's talk about another idea, this idea of constant returns to scale. Before we look at constant returns to scale graphically, we're going to introduce an economic principle that's necessary to make sense of scale. Minimum efficient scale. Now what does this mean? Okay, the definition's up here on the slide. Obviously we'll explain this. The lowest level of output where long run average total costs are minimized. In other words, what's the least number of units the firm can produce to achieve an average total cost per unit that's the lowest possible. So different industries will, by their very nature, yield a different minimum efficient scale. We've already introduced the idea of large scale and large manufacturing, and the principle that large manufacturing requires the company to produce a significant number of output to achieve an average total cost per unit low enough to compete in that industry, and it's only possible by achieving economies of scale. But let's talk about different type of industry, and we'll talk about how minimum efficient scale ultimately can determine the structure of an industry. So here's a review of economies of scale, right? The automobile manufacturers that we discussed earlier, they're all producing Q1 level of output, achieving an average total cost per unit of AC1, and any would-be competitor who is only producing at Q2 level of output has an average total cost per unit around double their large competitors, and this would discourage any firms from entering the industry. So let's analyze this economic principle of minimum efficient scale using our graph to explain how this principle will ultimately shape the structure of an industry. Unlike automobile manufacturing or the manufacturing of, say, earth movers that are produced by companies like Ingersoll Rand and Caterpillar, or producing airplanes, which is the business of Boeing and Airbus, light manufacturing or medium manufacturing requires some investment in capital, You must acquire a plant. You must equip that plant with machines. And obviously you must have some tools to complete the process. But the firm does not necessarily need to be the largest player in the industry to compete. So if we notice in this graph what's happening, over the range of this long run average total cost curve in the economies of scale region, average total cost per unit is falling, and it reaches a minimum at Q1 level of outputs. And what this graph suggests is that anywhere between Q1 level of output and Q2 level of output, average total cost per unit remains the same. So in other words, it doesn't matter if the firm is producing, we'll call Q1 100 units per week, or Q2 10,000 units per week. The average total cost per unit is going to be the same. Now, eventually, costs would turn upwards to diseconomies of scale. And we're going to talk about diseconomies of scale in more detail on the next slide. But for now, let's return to this idea of the area of constant return to scale and how that's going to affect or impact the structure of the industry. In an industry where there's some degree of manufacturing necessary to compete, so the firm needs to have some equipment and some machines and some physical plants, but they don't need to be extremely large, or they could be larger. In other words, maybe they own either one larger plant or several plants. You're going to have an industry where there's not just huge companies that dominate the industry. There's going to be some small players. There's going to be some medium-sized producers. There's going to be some in between there, and there's going to be some very large producers. The furniture industry resembles this graph. You have your massive producers of furniture, and and they're the ones that supply giant companies such as if you think about Ray Moore and Flanagan, they buy furniture from the companies that crank out hundreds of thousands. But there are also niche markets within the furniture industry. Some produce just locally, some produce specific antique furniture which resembles antique. Some may produce furniture for online orders only, right? The beauty of this is that it makes it easier for a new would-be competitor to enter the industry because they don't need to be as large to achieve an average total cost per unit to compete with the big boys, which ultimately is good for society because it means that if entering an industry is not protected by economies of scale, if a firm doesn't need to necessarily enter the industry as one of the largest producers, it will encourage companies to enter this industry, and obviously it'll give consumers more choice. So, the idea of diseconomies of scale. In the long run, growing large isn't necessarily always the best particular economic outcome. And there are several reasons behind what we call diseconomies of scale, where average total cost per unit of production can actually increase because you've grown, quote unquote, too large, too big. Right? When I was a kid, my dad used to say, "You're too big for your britches." It took me till I was 15 years old to look up that term. I didn't know what that meant, britches. But diseconomies of scale, okay? Control and coordination problems. In other words, if you think about your automobile manufacturers, and this is what happened to your Toyotas, and obviously it's happened to the American manufacturers as well, but Toyota used to be known for their quality. When you think about how a car gets from drawing board to showroom, there are a lot of players involved. There's a lot of eyeballs, and there's a lot of ideas, and there's a lot that goes into the process. So the engineers, the women and men who design these cars, they have a certain idea in their head, and they execute on this idea through computerization and generation. However, when you take that design and you try to implement it onto the factory floor, there may be problems associated with manufacturing that car that aren't not readily available when you look at them. Okay, so the desire of the engineer and the actual productive process, there may be glitches, there may be hiccups, there may be miscommunication, right? And of course, even the managers might not necessarily see their vision of the workplace carried out perfectly. So that's what we mean by control and coordination problems, right? This also plays in the idea of what we call communication problems. The idea of, well, what one party wants and what happens, and we call this idea the principal agent problem sometimes. You know, the owner of the business has a certain vision. Those hired to execute on that vision don't necessarily understand clearly or execute on that vision. Right? There are two other problems, and this is more so on the labor side: worker annihilation and shirking. If you work at a small factory or a small plant or a small business, you may, experience this yourself. The boss comes in and they know everyone's name and they treat you like family. And, they understand when you come in and say, my kid's getting his wisdom tooth pulled today. Is it okay if I cut out a couple hours early? And they understand because they see you on a regular basis. They know your name. They have a personal relationship with you. They know you'll make it up to them. They know you're a good worker. As opposed to a large factory where you may feel as if you're just a number, and when that happens, you may not necessarily be as vested in the outcome of your occupational efforts. Now, the other problem is even worse, the idea of what we call shirking. And that's the idea that if 100 people, or gosh forbid, 1,000 people are working at the same factory, there might be not only opportunity but incentive to say not work as hard as you necessarily have to. Right? Look, we're getting paid for 8 hours of work. They only say that we have to crank out 15 of these per hour. I'm going to make, exactly 15, even though if I put some honest effort into it, I could easily make 20. Right? So this idea of shirking may be more present if a company has grown extremely large. All right, there's no use crying over spilt milk. You heard this when you were a little kid. This idea of sunk costs. This is an important economic principle. Right? Now, what does this mean? Right? So the company's already paid for it. Costs have already been incurred, and they're irrevocable. In other words, there's no way you can get the money back. And we're going to employ here our old friend, marginal benefits, marginal costs. And the idea is simple, that a firm should stop engaging in any activity where the marginal cost exceeds the marginal benefits, and which will lead to an important rule of ignoring sunk costs because they are irrevocable. So this happens in the technology world. If you think about your current computer, right? Well, there was a big debate about how to engage the laptop and the desktop in regards to plugging in certain things as a mouse or a keyboard. And eventually USB became the standard. USB isn't necessarily the greatest technology. It was the technology that won out. Some have argued that there were better technologies. However, because USB became universally adapted, the other technologies were basically worthless. So if you were a computer firm, a tech firm, and you had developed a methodology for plugging in or communicating with a desktop or a laptop, and it wasn't going to be adopted by the computer industry at large, at that point it becomes a sunk cost, right? This happens all the time when you look at, say, the history of railroads. They start building a spur on the railroad, assuming that the spur would be directed at a profitable line based on a specific industry. A good example is what's going on with the coal industry now. You realize, hey, the coal has been reduced to from 50% of our electric production 10, 15 years ago down to like 28% now. So if you've spent the money and it doesn't make any sense to continue on with that project, right? Now, this applies to people as well. If you're 2 years into your degree and you think, man, this major I've chosen might not necessarily yield the occupational opportunities I envisioned, you have to say to yourself, okay, well, the marginal benefit of continuing this degree might be outweighed by the marginal cost of finishing with a piece of paper that doesn't necessarily present me with the greatest employment opportunities. Right? So ignore sunk costs. This wraps up video number 2, economic cost of production. Please look forward to you in the next video, which will be when we cover pure competition and the 4 market models.